Calculating light intensity is essentially for finding out a good interacting effects among a configuration of lights. By manipulating the intensities, you can produce various kinds of lighting effects. But it could be intimidating at the first place because there are lots of factors to consider about when calculating intensities, and you could be engaged in endless experiments before working out a perfect interacting effect. If you are a new user, you may have come up with 3 factors to control the intensities. There are light sources shape, distance among the lights, and the intensity proportion. Light source's shape determines the emitting direction of light. For example, a flat panel light source would only give out light on its positive side, while a severe light source would give out light on every direction. You may have mistakenly think that as the light source's shape changes, its influence varies. Well, it does change the area a light would influence, but when conflicting with other lights, its influence remains the same. Here is what I mean. This is the experiment we did in the last video. These 2 light sources have the same size and intensity. Therefore, they produce an equal influence to the scene. Now I turn off the lights and enlarge the red light shape. Pay attention that when a light source's shape is changed, you need to reset the intensity to update the light. Now I turn on lights again. As you can see, they still produce the same effect on the area they contact with each other. In this experiment, I changed the red light to an IES light with 600 lumen. According to the conclusion we made in the last video, it approximately equals to 60 watts of an incandescent light. Now I turn on lights again. Here you can see the red IES pattern under the influence of the blue ambient light. Ray trace and see the final effects. Now I turn off the lights. This time I would enlarge the blue light size. Reset the intensity because the blue light size has been changed. Turn on lights again. The red IES pattern is quite the same, which means it is not affected by the enlarged blue light. But distance matters. Here in this scene, the table lamp is so dim as the sunlight penetrates into the room nearby. This is the left view of the scene, and because these 2 light sources are so close to each other that the weaker light would be very dim. If I stretch the room, the sunlight would have less and less influence on the table lamp, and the yellow glow of the table lamp becomes more and more clear because the sunlight needs more and more bounce to reach the table lamp, and its energy attenuates or degrades along the way. But practically, Light source's shape and distance are nearly unchangeable in an interior, unless you are creating a studio lighting scheme as I have shown you in the last chapter, or you have to adjust the intensity proportion among the lights to control the interacting effects. Intensity proportion is a nightmare to new users as it appears to have infinite possibilities, but as we investigated the worst of experienced users, we find something really interesting, and I will call it 5:3:1 ratio. That is for the daytime scene. The ratio of key light to fill light to decorative light would be 5:3:1. In other words, the ratio of natural light to artificial light to decorative light would also be 5:3:1. In this intensity proportion, lower light would dominate the other, and the interacting effect would be in balance. Take this bedroom for example. Key light is the general light on the window, which illuminates the room. Fill light or the artificial light is the cuff light on the ceiling and the table lamps. And the decorative lights are those two IES lights on the decorative wall. First of all, I will set the key light to 500 watts, making it the largest light source in the scene. Then the cuff light. It goes around the room and could fill up the area that key light cannot reach. Here I set it as 300 watts. The table lamps can also be fill lights or decorative lights. Here I would like to treat them as fill lights because they can light up the corner of the room, so their intensity would also be 300 watts. The IES lights projecting on the wall are decorative lights, which would be calculated in lumen. As we have mentioned in the last video, 10 lumen approximately equals to 1 watt of incandescent light. According to 5:3:1 ratio, the IES light's intensity would be 100 watts in this scene, which is about 1000 lumen. Okay, turn on lights and ray chase. Now we can see the interacting effect with this intensity proportion. Lower light will significantly dominate the other, and the lighting pattern can be seen clearly. However, interior space changes all the time and the lighting style is always up to your personal favor. So you may need to adjust the 5:3:1 intensity proportion to get your favorite outcome. Normally, I would firstly change the key light's intensity, since it is the biggest light and has the greatest influence to the scene. Now I would increase its intensity to check whether I can get a better interacting effect. As you can see, the yellow glow diminishes gradually as the key light intensity increases, and the whole rendering would look pale white when the ratio comes to 10:3:1. On the contrary, if you reduce the key light on the window to a very low intensity or even shut it down, the cuff light or the table lamp becomes the key light, and the yellow glow will dominate the bedroom. If you add a night background or a curtain to the window, the scene becomes a nighttime scene. By the way, if there are something standing in front of the light sources, you have to take this object's transparency into account. For example, this curtain's transparency is 0.3. The key light on the window should be increased to 2000 watts to create the same effect as there is no curtain. So when start setting light intensity, you may apply 5:3:1 ratio to the light sources in your scene, then make slight adjustments, or maybe it is already the best result.